Hey everybody! So this is lesson 4, surface area pyramids, and this has some formulas that I want us to kind of think about a little bit. Okay, in order to understand these formulas, we have to understand what the slant height is, and we also have to kind of be able to picture this invisible triangle that is inside of every pyramid here. Okay. Because if you look at this awful formula they've given us for the surface area, it's got these radicals in it. Okay, why does it have radicals? Because of the Pythagorean theorem. Okay, and I'll show you why. So in a lot of these problems, they're going to give you the height, but not the slant height. Okay. In the formula, what you're doing here, if you think about the pyramid, if we were to unfold it, the slant height would be this right here that I'm drawing with a dotted line. Okay, picture taking apart that pyramid at the apex and folding it flat. It would look like this, and the slant height would be the height of these 4 triangles. So the base here would be length times width. Okay, in each of these triangles, you'd have 2 that had the length times the slant height divided by 2, right? Remember base times height divided by 2 for triangles. And then you'd have 2 other ones here that would be the width times the slant height divided by 2. Okay. Um, these these expressions that they have down here, these are for the slant height. So you can see in the formula, you've got length, width, that's the square base. Okay. All of this is for the 2 triangles that are attached to the width. And then this other expression over here is for the other 2 triangles that are attached to the length. Okay, so why the Pythagorean theorem? Well, again, a lot of the time we know the height. We know this length of the triangle is it's half the length of the base. This length here. See how it goes halfway across there? So this is the length divided by 2. Okay. And then the slant height, if you think about this, remember the Pythagorean theorem, that's going to be like your c. So c squared would equal the height squared time plus the the base of that squared, which is the length over 2 squared like that. Okay, and then we would take the square root on both sides to get just c. Okay, and so now you can see it's kind of starting to look like this here. And then the reason that they have the 4 in there is just it's to make the expression a little less ugly and not have a fraction built in here. But it also has to do with the fact that there are 2 identical triangles here and here. Okay, so just a little bit of kind of just big picture, like what is going on with this formula? Okay, it's because, again, the slant height is the hypotenuse of this yellow triangle that I've drawn inside the pyramid. Okay, um, if that's scary to you, just ignore it. You don't have to know where a formula comes from to use it, okay? Let's go ahead and just erase this stuff here and give this a try. Okay, let's go in the Wayback Machine before we knew that this formula related to the Pythagorean theorem. And we'll just do a problem. Oops. Okay, I don't know why it's not letting me. Sorry. Oh man, it's not letting me move my screen. There we go. Oh, finally. Oh, all right. Okay, so find the surface area of a rectangular pyramid with these measures, length is 8, width is 4, height is 2. I'm going to write this horrible formula down. So it's length times width plus 1/2 times width times the square root of 4h squared plus L squared plus 1/2 length times the square root of 4h squared plus w squared. Yikes. Okay, now we're just going to substitute in the numbers that they gave us. So instead of length, I'm going to write an 8. And there's another one here. There's one right here. Okay. Instead of width, I'm going to write a 4. Here's one here. Here's one. And then for height, I'm going to substitute 2. So there's an H right here. Oh, look at that. I messed up. This should be a 2 here. And the W was a 4. Sorry about that. Okay. The other stuff in the formula doesn't change. So I'm just going to bring it down. And then all of this is under a radical. All right. 1/2 times 8. This is 4 times 2 to the second power. And the W is to the second power. Okay, so remember how I'm always talking about GEMDAS or GEMS? The reason I do that instead of PEMDAS is that we don't have any parentheses here, but we do have grouping symbols. And in this, our grouping symbol is a radical. Okay, so I'm going to work under the radical first. And underneath the radical, I still have to follow the order of operations. So the first thing I'm going to do is the exponent. 2 to the second power is 4. 8 to the second power is 64. And then over here, I've got 2 to the second power, still 4. 4 to the second power is 16. I'm going to bring everything else down. All the other stuff is still with me, and I'm not going to work on it yet because I want to work one step at a time. Okay, so I'm still underneath the radical. I did the exponent, and now I am going to multiply. So 4 times 4 is going to be 16. Okay, that's all I'm going to do in this step. So you're going to get tired of me writing out all this stuff, but trust me, it's a good way to slow yourself down. Make sure you're following the order of operations. Make sure you're not making little errors and that kind of thing. Oh, and I already saw an error. I forgot to bring down this plus 64. Okay. If I had just been doing my work and not showing my work, I might not have noticed that, and I would have gotten the problem wrong and have to redo the whole thing start to finish. Okay, grouping symbol, did exponents, did multiplication, now I'm going to do addition. So 16 plus 64 is 80. 16 plus 16 is 32. Let's bring everything else down. This is from your practice. Okay, and so now I'm finally done with my grouping symbols. I don't have exponents. I do have multiplication. So I'm going to do that next. I'm going to use a calculator for some of it, but not all of it. Like 8 times 8, I can do that one in my head. That's 64. A half times 4, I can do that one in my head. Half of 4 is 8. So now I have 64 here. I have 8 root 80. And then half of 8 again is 4. Oh, that 8 should be, gosh, I'm making a lot of mistakes here. Okay. No, half of 4 here should be 2, not 8. Oh my goodness. Half of 4 is 2. Silly Miss Celestine. I'm gonna red pen myself here. That should be a 2. Okay, let's bring everything else down. Okay. And I'm gonna go ahead and use a calculator to figure out what these are. And it says up here to round to the nearest hundredth. So that's what I'll do. So I'm gonna go ahead and so we have root 80, square root of 80. There we go. So it's like 8.94. Um, and then I'll find the square root of 32. That'll be next. Do this. 32. Square root of that is, it's about 5.66. Okay, because the 6 will round up the 5 there in the hundredths place. 5.66. All right. So I'll go ahead and multiply those, and then I can add everything together. Oh, so 2 times 8.94, 17.88. And then I'll do 4 times 5.66. 22.64. You've got to add those to 64. Okay, This is my answer, 104. And then I'm going to get the decimal. 0.52. It is square centimeters. It would go here. This is item 1 from the practice. Okay. Look at all that work we had to do. That was awful. Okay. I don't know how else to say it. That was just a lot of work. Make sure you're showing your steps, just doing them a little bit at a time. Okay. Let's see what's going on with this one. This one's from your quick check. No, it's from your practice. Do I have any quick check problems here? Oh, that one I just wrote on top of it. Okay. Let's see. What is the surface area of a square pyramid? I'm going to draw it. So the base edges are both 8 because it's a square. Draw the apex. So I draw like a tilted square and I do the back sides with dotted lines. Then I draw a dot above it and connect to it. And then it looks kind of 3D. And then the slant height, this time they're giving us the slant height is 16. So I get to do this one a much easier way, okay? Because this one is a square pyramid. That makes things easier because see how we had these two expressions, 1/2 width times yuck, and then 1/2 length times yuck? That was because in this pyramid, when you have a rectangular base, you have two squares that are the same and then two others that are the same. But guess what? With a square pyramid, you have triangles, not squares. You have 4 triangles that are exactly the same. Okay. So what we're gonna do here is just find the area of the base. That'll just be 8 times 8 because it's a square. Okay. Then we're gonna find the area of each of these 4 triangles. So those are gonna be length times width divided by 2. And then we've got 4 of them, they're all the same. So we'll just times that by 4 and we'll be good to go. Okay. The 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 triangles, remember triangle formula is I should have put base times height here, not length times width. I'm gonna red pen myself again. Base times height. Okay. And so the trick here is realizing that the height is 16. It's the slant height because the triangles are making up the slanting sides of the pyramid. And then the base would be 8. So here I'm just going to have 16 times 8, base times height. I'll divide by 2, and then I can multiply by 4. Okay. Oh, what is 16 times 8? Is 128. Yeah, half of that should be 50 plus 14, 64 times 4. Okay. And then look, we're going to add 64 to that. So I might just take 64 and multiply by 5. 320. All right. And there it is right there. Okay. I know this video has gotten super long. If you stuck with me, good for you. I hope you're watching me on like double speed here. I'm talking kind of slow. Or at least maybe 1.25 speed. And then there's just one last comment here. It's going to go with what we've been talking about, which is that the area formula for triangles, so the area of a triangle is base times height divided by 2. Okay, and so you can see that in the surface area formula. Okay, so this first one is the base, that triangle on the bottom of the pyramid. And then here we have plus 3 times 1/2 length base. Length base, see how, well, it's L for slant height. They're finally using L for slant height. So, see, those are the three triangles that are attaching to this triangular base here. So you've got the base plus the three triangular faces. And that's what's in the formula there. All right, guys. Thanks for making it to the end.